We're now going to prove whether our shape is a rectangle or not on a coordinate plane. So it tells us I have a quadrilateral PQRS is located at those coordinates. Determine whether PQRS is a rectangle by using the distance formula. This one is going to require a lot of distances. I'm not going to go through showing you how the distance formula works. We've been doing distance formula for quite a while now. I'm just going to show you what you would need to find the distances of. So in this case, just like what we did in section 3 to show that something was a parallelogram, we are going to do the same thing. You need to find the distances of all the side lengths, which in this case would be PQ, QR, RS, and PS. Again, your distance formula looks like this. So I'm going to start by listing what these distances are. PQ is square root of 52. QR is going to be the square root of 13. RS would be the square root of 52. And PS is going to be the square root of 13. Now, all this does, when I find the distances of my sides, I'm showing that opposite sides are congruent. However, that is not enough information to tell me that PQRS is a rectangle. In fact, all this shows me is that I have at least a parallelogram. So I need to continue using the distance formula to show a property that satisfies a rectangle. And one of the properties we know is that our diagonals, in this case QS and PR, are congruent. So we also need to show the distance of PR and QS. If PR is equal to QS, then I know it is a rectangle. So those two distances, just going to list those as well, would come out to the square root of 65 and square root of 65. Again, use your distance formula with the coordinates up there, and you'll come up with those distances. So now we know that this is a rectangle. And the reason that it is a rectangle is because our diagonals are congruent.